when we are asked if a precipitate will form, what we need to do is calculate our ion product and compare it to our solubility product. Let's first write a chemical equation for this. The reaction that we're talking about is lead ionizing. And don't forget, this too is very important because it comes into play in a lot of these calculations. So if this is our equation, then our solubility product is this, and we know what that equals. We were told when we write this, these concentrations are equilibrium concentrations. So when I multiply this out, this is going to be the maximum number that I can get, and it still be dissolved. This is, in fact, at this number, we have a saturated solution. So I think I said it this way before. This is how I think about it. If we multiply those out and the answer comes out higher than this, then we know we have too much dissolved and a precipitate will form. If we take concentrations and multiply like that and it comes out lower than that, then we are not saturated and more precipitate could dissolve. But when these are equilibrium concentrations, we get this number. So all of that is another way of saying that we're going to use Qc, which we call the ion product, and it is the same thing I was pretty much just saying. That we're going to take these numbers and put in any concentration. To see where you're at. In other words, to compare it to, you compare the ion product to this to see where you're at. If it comes out too higher, then a precipitate is going to form. So we're going to plug those numbers in that were given, the concentrations that were given. Let's compare side by side with our solubility product. And we can see that it's way too low. So since the solubility product is a product of the two ion concentrations, if this number is too low, it means we don't have enough ions. That means that the reaction will go this way. In other words, no precipitate.